Look at a major construction site. You see cranes swinging steel beams, concrete pouring, and hundreds of workers moving simultaneously. It looks like organized chaos. But none of that physical movement is spontaneous. Every single action on that site, down to the placement of a single anchor bolt, is governed by a strict hidden language. This language relies on two core pillars. First, there are the visual plans, which map out the physical geometry of the building. Second, there are the textual specifications, which act as the rigorous instruction manual. Misinterpreting a load-bearing detail triggers a chain reaction of delays, structural failures, and multi-year legal battles. The physical structure you see in a city is really just the final physical echo of that meticulous legal documentation. The visual plans provide the spatial geometry. They dictate exactly where the property boundaries are, where the walls intersect, and the pathways for plumbing pipes. But geometry isn't enough to make a building stand up. The specifications provide the chemistry and the legal standards. They dictate the exact strength of the concrete mix, the required brands for the fixtures, and the step-by-step procedures for installing them safely. In Australia, the standard for this textual language comes from NATSPEC. They provide comprehensive, legally vetted construction specification templates to ensure uniform quality across the entire industry. These documents are tightly controlled and watermarked to a specific project address, effectively locking that precise legal language to one exact piece of dirt to protect against ambiguity. A builder must constantly cross-reference the two-dimensional lines on the visual plan with the dense paragraphs in the specification. You cannot safely construct the geometry without strictly following the required chemistry. Before you can read a single line on those plans, you have to check the title block. This is the document's passport, the essential verification required for every person on the project. This block highlights the date drawn field, telling you exactly when the layout was generated. Next to it is the revisions ledger. It tracks every sequential change, listing what element was altered and who authorized it. If a site manager accidentally issues an outdated Revision B plan to the carpentry team, they might build an entire floor with the wrong dimensions. The financial liability for tearing it down falls entirely on the builder. Interrogating the title block is the absolute mandatory first step. Until you verify the version history, you cannot trust a single line on the page. Construction begins with an empty dirt lot. To understand what to do with that raw dirt, builders turn to the site and civil plans. This site plan shows contour lines representing topographic elevation changes. They map the natural shape and slopes. Embedded within are specific elevation numbers. A drop from 77 to 76.25 tells the earthworks team exactly how much soil to cut or fill for proper water drainage. These plans also define the strict legal limits of the project. Property boundaries and setback lines dictate exactly how close a structure can be built to the neighbor's fence to comply with zoning laws. The geotechnical report provides the invisible subgrade reality. It details the exact soil composition underneath, telling the engineers whether they are building on shifting sand or solid bedrock. Construction cannot begin until the visual footprint on the site plan is perfectly reconciled with the invisible chemistry detailed in the geotechnical report. Once the ground is understood, the architectural plans dictate the overall aesthetic vision and physical scope of the project. The architectural floor plan provides a top-down view of the building. It maps the arrangement of rooms, the flow of circulation paths, and the exact dimensions of every usable space. Elevations and sections act as vertical, cut-through slices of the building. They reveal the overall height, the exterior materials, and the internal volumes of the rooms. To track all the specific components, architects use a schedule of windows and doors. This is a master inventory list specifying the exact type, size, and material for every opening in the building's exterior. Architectural plans provide the vital instructions for what the building will look like and where everything goes, but they rely entirely on the engineering disciplines to figure out how to actually hold it up. That heavy lifting is detailed in the structural plans. These drawings form the building's rigid skeleton, ensuring it maintains strength and stability against external forces like gravity and wind. The structural plans detailed the exact foundation system required. Depending on the soil and the load, this could be a suspended concrete slab poured on site or a traditional timber frame resting on block walls. This structural diagram shows how a steel column anchors into a concrete footing to transfer roof weight to the earth. The column rests on a 20mm grout pad for a level base, secured by 4 heavy-duty anchors. Furthermore, the specifications dictate that any steel in direct contact with the ground must be chemically treated to prevent corrosion over the lifespan of the building. This wall bracing plan shows how the structure resists lateral forces, like strong winds trying to push the building over. To prevent collapse, the details require fully welded 65 by 65 mm steel cross-bracing to lock internal walls into a rigid grid. The structural plans strip away the aesthetics. They translate the architect's spatial vision into a physical object bound tightly by the laws of physics. With the skeleton in place, the services plans map out the building's internal organs, the hydraulic, electrical, mechanical, and gas lines. Routing these systems is a massive puzzle. Thick electrical conduits and plumbing pipes must weave through the structural skeleton without cutting through critical load-bearing beams. Once the internal systems are placed, the physical outer skin, the brickwork, cladding, and roofing, is applied to seal the entire structure from the elements. This outer skin is called the building envelope. The visual plans show where the cladding goes, but the specifications dictate the exact sequences for applying the waterproofing membranes, the metal flashing, and the thermal insulation inside that envelope. A failure to perfectly integrate the internal services with this outer skin leads to catastrophic water leaks, building code violations, and compromised structural integrity. The final internal phase involves the finishes. The specifications dictate exactly how the substrates are prepped, which fixtures are installed, and the precise paint schedules applied to the walls. At the same time, the focus shifts back outside for the final integration of civil engineering and landscaping on the site. These civil detailing diagrams show exactly how external infrastructure is built, mapping pedestrian pathways and sidewalks for safe accessibility. They also dictate the placement of subsoil drainage pipes and concrete access chambers that manage stormwater runoff, preventing flooding. These finishing documents represent the crucial moment where rigid engineering systems are covered up, creating a safe interface for human occupants and the natural environment. This diagram shows how a completed building is really a perfect physical alignment of distinct overlaid disciplinary plans. Every successful construction project requires combining the precise spatial geometry of those visual plans with the rigorous material chemistry of the textual specifications. Reading these plans is primarily a diagnostic exercise. A site manager constantly cross-references these overlapping layers to find physical contradictions before the materials are ever ordered. And through it all, the title block remains the ultimate governor, ensuring every single contractor on site is operating from the exact same version of reality. Mastering this hidden language of documentation is the only reliable way to accurately predict, control, and ultimately construct the physical world around us.